Okay, now we're going to try to do a little introduction to quadratic functions. We took a little look at it using the algebra tiles, and now we're going to look at it more algebraically. So a quadratic function is indicated because the biggest exponent is a 2. So that 2 right there is what's making this a quadratic function. It's actually a quadratic expression because I have no equal sign, but that's neither here nor there. The first term, the one with the x squared, is called the quadratic term. The one with the x is called the linear term. And the one with no x is called the constant. Now, you can have at most 3 terms, but realize this could be a 0, and then you'd have no linear term. You just have the quadratic term and a constant, so you'd have 2 terms. Or they could both be 0. This 7 could be a 0, and this 3 could be a 0, and then I just have 2x squared. But it's still quadratic because of that square. So, and we always put them in descending order like this. So you have your biggest exponent followed by your next biggest exponent, with the last term being your constant. Okay, so that's the basic form of what a quadratic is. When you graph a quadratic, instead of getting a line, now you're going to get something called a parabola, this U-shaped thingy. All right, and so I have 2x squared plus 7x plus 3 graphed over here. First thing I'm going to point out is, just like with a line, when you plug in a 0, the thing you get out is the y-intercept. So if I plug a 0 in here, this will turn into 0, this will turn into 0, and then I would just be left with a 3. So the place where it hits the y-axis is the constant. All right, and then the other special places, so if that's the y-intercept, please note I got 2 x-intercepts over here. With a line, we just had 1. Now with a parabola, with a quadratic, you can have 2 solutions. This will be the first solution. This will be the second solution. We're going to get more into this with the graphing, but you can look over here from the factors. If you look at the factors, let's see, what's true? When it hits the x-axis, the y value is 0. That means that this whole equation has to equal 0. Well, if I have 2 things multiplied together to give me 0, one of them has to be 0. When is x plus 3 equal to 0? Oh, when x is equal to negative 3. There's one solution. And when is 2x plus 1 equal to 0? When x equals negative a half, which is my other solution. So that's how you can look at the graph and be able to work backwards to what the equation was. All right, and then when we had lines, we had, other than horizontal and vertical, you would always have an x-intercept and you would always have a y-intercept. But things can be different for parabolas. You have 3 possible outcomes. You could have 2 real solutions. That's when the parabola hits the x-axis twice. You could have this scenario where it just comes down and bounces off the x-axis, goes back up. Then we say it's got 1 real solution, but that's going to be called a double root. Hopefully we'll be able to get to that. And then if you look over here, this parabola never actually hits the x-axis, but we're going to find out it still has solutions. They're just not real. We're going to introduce something called imaginary numbers, and that takes us to the complex plane. So I don't think we're going to get to that this year, but that is a possibility. You can have solutions that aren't real. Just what you always wanted in math. All right.